Hi, Jolene. How you doing?
Good morning. How are you?
Did you manage to get the colligative property lab entered?
Think so. Yeah.
Honestly, that was horrible.
Once
I,
you walked me through, I thought it was fine, but if you didn't show me the roadmap, it would have been.
oh dear God, I'm really not kidding you. I've been doing this work for 40 years. It took me 4 hours to get through that thing.
Yeah.
And
I
even,
mean,
oh, go ahead.
and at the very end, at the very, 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 very end, when it asked for the Van Hoff,
Mm,
you could click a little button and it would show you all the formulas for every single problem, but it didn't
yeah,
show you to the end. So it was
yeah.
kind of like, what was the point of that?
Um, this one's a little better in that regard. There is a button that you can press to kind of help you through things. But Jolene, I didn't even see that button.
That was at the very end and it was in the bottom. Need help finding the Van Hoff? And I clicked it just to see what it would do because I'm one of those people that just see what you can get out of the,
Uh-huh.
the application we're using. And it had every single formula. And it told you like solvent with solution minus the it told you everything. It told you what to do. That one problem that I got hooked up on, it told me word for word what you told me to do. It had it in there like it was a lab manual.
Jolene, I'll be honest with you. I would take notes on what you just said because what you said is absolutely vital. But I am going to fight tooth and nail not to do this again.
Yeah,
It's
it's nothing even close to a real lab simulation. So
who's there? Who's there with you?
When you're, I'm sorry, my daughter.
Oh.
She's just waking up.
As am I. As am I.
I know. Make my coffee.
I'm going to leave you for a second. I'm going to get a second cup of coffee and I'll be right back. Okay.
Mom, does that mean can I put it back in the refrigerator?
I think so, freezer.
Yeah, because it melt. Totally melt when I was eating for a lot of hours. Sometimes it pops. Sometimes it pops. And my bunny. There's two bunnies.
Okay, I'm back, Jolene.
I see you. How do you drink your coffee?
Cream and sugar. Well, for the first cup, the second cup is just a coffee and cream.
Yeah.
Why are you planning on making me a cup?
I'm making me a cup of coffee now. Oh,
hello. What's your daughter's name? What's your name?
Nadia.
Nadia? That's a pretty name. Where did that come from? Did they just magically decide to call you Nadia?
No.
No?
I was in
You're Portuguese.
do the last face. Wait, and then
Nadia, do you have a little dog? You have more than one little dog. Is that a basset hound?
A basset hound, yeah.
Oh, God bless you. How long has he owned you?
10, 11 years.
Oh,
But
basset hounds. Jolene, I have more stories about my basset hound than my other 5 dogs combined.
What you have a basset hound?
I used to, yes. I have more stories of that basset hound than the other 5 dogs combined.
Yeah, same here. Charlie has lived 1,000 lives for sure. And I could write a book about it. I mean, the things that he's gotten away with, the things that he's done is just insane. And he's defective. He doesn't howl.
No, my Basset Hound didn't howl.
Yeah, sometimes they howl and they don't stop, but this one doesn't howl at all. I mean, he'll bark, but he didn't howl. What's that?
Find yourself this, get online and find yourself this book. It's called The Basset Hound Owner's Survivor Guide. It is hilarious.
Oh, I'm gonna have to find it because I mean, he's eating fireworks, he's gone under the Christmas tree, open presents. You need to go wake up Nella and find something to do, okay? What are you doing? Oh, a nice whistle.
No, I wish.
He's ran away to the point. Go wake up Nella. I'm in class. Go wake up Nella.
Put that in my door.
Okay. He ran away so many times that all of my neighbors knew him by name, and they would leave a note on my door with their address and said, "We have your dog," when he was a puppy. And one time he was trying to cross Del Mabry in the rain. And I live in South Tampa, so it's really congested with traffic. And he, some lady, go talk to Nella, please. And he jumped in her car. So I found him on Facebook. And then she says, "Well, let me keep him for you when you go out of town, if you ever do that. He's just so cute." I said, "Are you sure?" She's like, "Yeah." I'm like, "It's kind of a hellion." So I forgot to tell her that he could get out of his kennel to put like a latch on it. And he got out of her kennel. I guess he didn't like her, and he's never done this at my house, but he jumped on her bed and peed on her bed.
Ooh.
So when I came home from my vacation, she was outside waiting for me with the kennel and the dog. My phone was ringing the minute that I landed at the airport. It was so funny. I was like, I guess I won't be seeing her again. And I mean, like, he's just had so many stories. He's just been a part of everything. He's been a great dog.
I once left 3 adults in charge of 1 Basset Hound in my parents' backyard. She got away.
They get away.
That's-
And Charlie doesn't run away. He walks away. And we live close to a hotel. And to this day, if he gets out, he'll go to the hotel, especially on Sunday mornings. And he just walks. He doesn't run. Again, he's 10, 11 years old. He walks, and he walks through their sliding doors, and he goes to their buffet bar and he eats their bacon. They think he's the cutest dog in the world, but he just follows his nose like Toucan Sam. And they're like, "If you don't want him," I'm like, "Of course I want him." I'm like, "He wants your bacon, you know?" It's the funniest thing in the world.
Charlie's looking his nose.
Okay, go get Nella awake. So that's my dog stories. I've got more. He's got picked up by our vet one time crossing the street. He got picked up by a doggy day camp lady and spent the day at doggy day camp before they got his microchip and called me. And I went to the doggy day camp. I mean, it was so nice. It's one of those hipster ones close to town. It was incredible. I wanted to go there. And he's just having fun, walking around, just having the best time of his life for free. Go.
Wait, Mom. We had cookies.
Yeah, I know. Let me get her settled down so I can.
No, take your time.
Come on. You need to come in here.
I got nothing.
Just her. Go for it. Okay. Now, the last lab that I turned in, the paper lab, did I turn that in correctly?
Jolene, I haven't even had a chance to look at it. I
Because
taught a lab from 8 to 9 o'clock yesterday, hopped in a shower, got out, went to SPC. I was at SPC from 9:30 until 8 o'clock at night, came home, ate dinner, and I literally crashed out. So I haven't seen anything.
So we turned in the regular lab portion with the data to the one lab post, and then the other lab one was the post lab portion.
You should have turned it in both portions of the colligator property lab, which was through McGraw-Hill, which was the experiment and then the post lab afterwards.
What about the Tuesday lab?
I thought that's what that was. Oh, the heat of vaporization lab?
That's the one that had two different components to turn stuff in. So I
You
figured
had a pre-lab and let me go.
we had a pre-lab lab and a post lab.
Yeah,
but
you
it
should
necessarily say it that way. It said it on the.
Okay, are you seeing the screen?
Yeah.
Okay, you should have turned in this thing right here, this thing, and the discussion. You should have done the discussion.
Yeah, I did all of that. But on my phone, I don't know why it didn't. It had two different separate ways to enter in that data sheet. So I broke it up. I put the regular lab into one and the post lab into the other, because there was a post lab component to the printout.
Okay, that's discussions.
In discussion I did a while back.
Yeah, I may have to find it myself.
It was really weird the way it was worded on my phone, and I don't know why it's not. It's just silly. This whole
I have 22 submissions.
And I submitted twice to two different components.
Okay, I got you up here. Yeah, I got it.
But then my post lab is somewhere else. And then I screenshotted my.
Okay, I've got 2 data sheets. I got 4 things from you.
Oh, good. Yeah, that's my actual graph. And that's my post lab.
Nope, I got 2 graphs here.
Okay, yeah, that's.
I don't have the post lab.
The post lab I sent in and something else that it asked for another assignment. I can take a picture of my post lab and send it to you. That's what I was worried about, because the
This
post
thing,
lab,
right? This thing.
See, it says post lab on top.
Yeah, I don't have it for your submission, so
I have it here.
go ahead and submit it. I don't know why.
It asked for 2 separate things and it made me nervous because I couldn't find the second thing. So I just figured it was post lab.
I'm pulling my hair out over this lab, Jolene. I'll be perfectly honest with you. It's like,
So am I.
it's like I'm supposed to
Because it's
answer
such a different
questions.
form.
Just resubmit it, email it to me, and I will grade it for you. Okay.
Yeah, I'll do
All right.
it here.
I don't even know. I don't even see what you're talking about in that.
It was on my, it's not on there. It was on my Canvas as things to do, as a list of
Okay.
things.
I've got student view up there now.
It was on my Canvas, on my phone.
Okay, I've got the heat of vaporization.
That's what mine looked like online. But on my list of things to do, it did not look like that. And you don't see it from that view. I don't know how you find it. It's from my cell phone.
I don't know what to tell you.
Yeah. So I didn't know, and I didn't want to bother you because it was Sunday and you said you weren't there.
Please bother me. Okay, seriously, please bother me.
Yeah.
I know I sent that email out. That turned out to be false. I thought my wife had planned a dinner party for like 3 in the afternoon, and it was like at 6. So I was
Oh.
actually free.
I have it here. Post.
Just take a picture and send it to me in an email, Jolene.
Yeah.
I'll make sure that I update it, okay?
I'm gonna do it right now because I have the picture. Oh, I don't. I have to retake the picture.
Okay. I might as well do that. Screw it.
Yeah, post lab. There it is. Go to here. I wanted to plus. What? Oh my God, when I hit general chemistry 2, oh, that's why.
Don't scare me like that.
Shoot. 21, yes. Chemistry 2, teachers.
I'm trying to stall right now, Jolene, because I'm hoping somebody other than you gets in here because people are going to be,
Stop,
mean-
dog.
if you didn't get through,
You didn't get through what?
if you didn't get, why is that doing that?
Almost done.
This
Use,
is, I didn't save it. Is that the reason that I didn't save it? Okay, I'm sorry. I'm trying to see what you're seeing. And I can't do that because it's locked me out. And looking as a student, it's locked me out because I had the dates done for
if you
the,
want to see what I can see, I'll show you how to do it. Scroll all the way up to the top.
okay, okay.
Okay, is that student view?
Yes, I'm in student view.
There should be a way to change. Okay, go to calendar and see what's due in calendar. The calendar is far left in the blue bar.
Yeah, but I'm not seeing calendar.
Far left.
Far
the
left.
blue-
Oh,
And usually it tells you what's okay. So if you look on the 6th, you see collaborative properties post lab, collaborative properties, discussion lab. And is there any more on that one? That
you-
was one. I did that collaborative properties. I can barely read. I need my glasses. I'm on my phone. Discussion lab safety. I had 2 intermolecular forces. I had intermolecular forces and I had heat
okay,
vaporization.
were you able to access it?
Yeah, I put my post lab in one of them. Yeah, you'll end up finding it by the end of
No,
the year. but
okay. From
there's
now on, don't go to calendar.
yeah, it
Okay.
automatically derives in my phone somehow. I'm just gonna do it online. I'm just gonna scan and upload it that way.
I'm sorry, Jolene, but you go through modules
Okay.
because you can see what happens is it may have sent you to a site that was not published now.
Got
And
it.
that might be a site that it's not my website, so it's hard for me to.
I
so-
just emailed it to you anyway, so you're gonna have that.
Okay, good enough. Who is Shar? Okay, Shari.
Yay, more people.
Shari, your first time here. Nope,
Mhm.
I'm sorry. Shari, You have not been
Hi.
attending, Sheree, you have not been attending lecture.
I've been a little like confused with the times. And for like the past few days, I've been working on Tuesdays and Thursdays.
Well, I'm sorry, but the time is, it's a different type of class. The class that is on the lecture is a mandatory attendance class. The
Okay.
lab is not. The lab is not a mandatory attendance, but the lecture is.
Okay.
All right.
Mm-hmm.
Today you don't have to show up because it is a test day. You have to take the test sometime between 8 and 5 today. But normally it is it's considered a live online class. What a live online class means is we block off a section of time that we say, okay, the class will be taught during these times.
Okay.
So you have to attend that. If you don't, it will affect your participation grade. All right.
Okay. Mm-hmm.
All right. So let's get, all right. First off, guys, I need to do a secret number. I need to do a secret number so I can discern whether or not people have access to recording afterwards.
Don't.
In other words, I know you guys have been at the meeting, so you've seen this. So if you ask me questions later on, what's going to happen is I will go into as much detail as you want. However, people that don't attend this Zoom meeting are going to have to come up with these two numbers. One I'm going to give you right now. The other I'm going to give you somewhere in the midst of the lecture. And this is to see that people have looked at the video. So when I ask them if they viewed the video, I'm going to ask them to prove it by giving me these two numbers.
I still can't find the videos to begin with.
They're at the very end.
Oh, of this thing.
Go all the way down. See here?
Okay. Yeah. You know why? Because inside of McGraw-Hill, it has recorded as well. So I was looking there.
No, you go all the way down here, and what
I see it.
happens is I've got a Word document, and the Word document has all of the meetings on there with all you got to do is click on it, and it will give you,
I see it.
okay?
Yeah.
Good enough. All right. So, all right, are you seeing the slide, the thing that says the experiment right now?
Yeah.
Shari?
Hold on. Say that one more time.
Are you seeing,
Mhm.
on the screen right now, are you seeing a slide that has the first two words, the experiment on it?
No, we're seeing your
No, that's fine.
we're seeing
I have
your
a
other
tendency to start talking, and then about 5 minutes later, somebody says, Mr. Popovich, are you supposed to be sharing your screen?
Okay.
How are you seeing it? Now
Yeah,
you're
now
seeing
we're
it.
seeing it.
now we see the experiment. Yeah.
Okay,
Wait,
first-
you give us the first number.
57.
Okay.
Okay.
All right. Overall, what we're doing today is we are studying the experiment H plus H2O2 peroxide plus thiosulfate S2O32 minus. That yields 2 waters and the tetrasulfur deca oxide
Big word.
polyatomic. Are you seeing that?
Yep.
Yeah.
Overall, that is the chemical experiment we're doing. The reaction is catalyzed by iodide, okay? And it occurs in 2 separate steps. First one is the iodide reacts with an acid and peroxide to make I3 and water. and that reaction is really, really slow. Second reaction, we take the I3 and that reacts with the thiosulfate to make 3I minuses again and the S4O8. So if you remember from lecture, when we're dealing with mechanisms and kinetics, the rate law is always going to be related to the slow step. So to determine the rate of the reaction, we have to look at the disappearance of the H2O2, because literally the I3 is going away. Does that make sense to you both?
Mhm.
Sheree? Is that
Yeah.
making sense?
Mhm.
All right. So the trouble is when I'm looking at these reactions, I've got a clear solution going to a clear solution. So I can't observe anything. So I have to use a third reaction that will trigger a color change. Now, it so happens that I3 will react with starch to make a brilliant blue color. So the first reaction creates the I3. The second reaction destroys it. Okay, so as long as both of these reactions are going, then I know that the reaction is proceeding. As long as both of these reactions are going, I have no I3 because it's getting destroyed by the S2O3, and therefore I have no blue color. When I run out of the S2O3, the I3 starts to build up a concentration. It reacts with the starch. I get a blue color. Is this making kind of sense to you now?
Mhm.
So basically, if I know how much S2O3 I start with, then I know how much I end with because I have nothing left. If I have no S2O3 left, then there's nothing to react with the I3, and that can go ahead and make the blue color. So my final concentration of S2O3 is 0. My initial concentration is what I start with. Again, is this making sense to you? Sorry?
Mhm.
Okay. So when it's used up, we know all we got to do is, as soon as we add all the ingredients together, we hit the stopwatch. When it turns blue, stop the stopwatch because all of the S2O3 has been used up. So now I've got the change in concentration with respect to the S2O3. So therefore, I've got to change in concentration. I also know how much time it took. I can get the rate with respect to the S2O3. The trouble is, the S2O3 is the fast step. And remember, I said the overall rate of the reaction has to come from the slow step. So what I have to do is I have to relate the rate from the thiosulfate back to the rate of the peroxide. And there was a slide that I gave on the lecture that said the rate of one of the reactants is related to the rate of the other reactant by taking the coefficient in front of both reactants and dividing by it. So in other words, if I'm looking at the rate of H2O2 and the rate of S2O3, they're related. The rate of H2O2 is equal to half of the rate of the S2O3. This is because I'm using up 2 S2O3s for every 1 H2O2 that's getting destroyed. Again, is this kind of making sense to you?
Yeah.
Okay. Now, the experiments we're doing in this procedure, the first three, what we do is we vary the concentration of the peroxide to see the effect on the reaction rate. So we must keep, because I've got three things here that I'm dealing with, I must keep the I minus, the H2O2, and the thiosulfate. I must keep all three of those things at the same concentration. I'm sorry, excuse me. I must keep the iodine and the thiocyanate at the same concentration and vary the H2O2 to see the effect of the H2O2 concentration. Does that make sense, guys?
Mhm.
Now, if you've tried to do the experiment, you're going to notice that you use varying amounts of water and you use varying amounts of the peroxide. You do varying amounts of the peroxide because we want to see different amounts. Okay? But you have to understand we are dealing with the overall volume. If I put 10 milliliters of the I minus and 1 milliliter of the S2O3, if I don't add any water and I just add the 10 milliliters of H2O2, then the next experiment, if I just add 7.5 milliliters of H2O2, I've also changed the iodine and the S2O3 because I've gone from 21 milliliters down to 18.5 milliliters. Does that make sense, guys?
Mhm.
So that's the reason we're adding different amounts of water and peroxide. The total volume, if you notice, the total volume of the water and the peroxide doesn't change. It's both of those add up to 10. All right.
Mhm.
Now, for the second three trials, what you are doing is you are adding the same, I'm sorry. Am I here? Okay, I'm trying to get this. Let me move you guys over here. For the second three trials, what you're doing is you're adding the same amounts of the iodine, thiosulfate, and the peroxide. So you're not going to need any water. In each of this instance, you're adding 10 of this, 10 milliliters of this, 1 milliliter of this, and 10 milliliters of the peroxide. You don't need any water because the reason for the water was to keep the iodine and the thiosulfate concentration the same. So here you're keeping all three concentrations the same, but you're changing the temperature to see its effect on the reaction rate. Now, are you with me so far, guys?
Mhm.
Jolene is somewhere else right now. There she is. Jolene, you understanding?
Yeah, I'm right here. I'm listening. I just had the mute
No,
button.
that's fine. All right. So we're adding 4 solutions to the beaker
Yep.
so that the final volume is going to be greater than the initial volumes of the individual solutions that we added. Don't be thrown by the small m, big M term.
No.
What that stands for is millimoles, and that stands for 1,000th of a mole.
Yeah.
They work the same way as regular molar units. Don't worry about it. Okay? So right now, what you're going to be doing is you're going to be getting the new concentrations. And you are going to use the simple equation M1 V1 equals M2 V2. The first concentration times the volume of that first solution is going to be equal to the final concentration after you've added all the things together times the final volume. In this case, for the iodine, we're going to have the, oh, I'm sorry, I may have it here. Here we go. The first concentration for the iodine is 63.95 millimolar. The original volume is 10 milliliters. I took 10 milliliters of this solution, put that into the beaker. I put 1 milliliter of this concentration S2O3 into the beaker. I put 2.5 milliliters of the water into the beaker. And I put 7.5 milliliters of the peroxide into the beaker. To get the iodide concentration, I have to multiply the concentration times the original volume. That's going to be equal to the new concentration times the total volume of all 4 solutions. 10 plus 1 plus 7.5 and 2.5 adds up to 21. So my new concentration of my iodine is going to be 30.4 millimolar. Everybody on board here?
So
Mhm.
far.
Okay. To get the reaction concentration of the S2O3, I take the concentration of it times its volume. That's equal to the new concentration times 21. Peroxide, 27.53 times 7.5 is equal to new concentration times 21. Okay, we all good about this?
Mhm.
Mhm.
All right, so what's happened is I add the iodide, the thiosulfate, and the water into the beaker. Then I take my peroxide. Guys, when you are doing this simulation, it happens fairly quickly. So it's not easy getting that pipette into the waste bin. But what you have to do is you have to squirt in the peroxide, put that pipette over by the waste bin, and then once you do that, the screen will flip and the timer begins. You watch that timer. It's going to flip blue instantly. When it flips blue, hit the button immediately. If you miss the button, here's the pain in the ass part of this. If you
Redo.
miss the time, if it goes too long, it will say there was an error. You clicked the clock too slow. You got to do the whole thing over again.
Yeah.
It's just the way the simulation is. So now you are going to have the original the concentration of your thiosulfate in the beaker initially. You know what it is at the end because it has to be 0 because you saw the blue color. The change in concentration, final concentration 0 minus the initial concentration of 0.56. That gives you the change in concentration for your thiosulfate. You divide that by the seconds on the clock. That gives you the rate with respect to the thiosulfate. Are you with me so far?
Makes
Mhm.
sense.
All right. Now, that's just what I explained here. So if it took 66 seconds for the reaction to occur, I take the change in concentration, divide that by the time, and I get minus 0.0085 millimoles per second. Remember, this also is a reaction rate from a reactant. Reaction rates from reactants are multiplied by -1 because reaction rates are always positive.
Yeah.
When you're looking at reaction rate from a reactant, you're changing the concentration from something that was high to something that's low. So when you subtract final minus initial, that's going to be a negative number. In order to relate that to the amount of products that are forming, we have to multiply reactants by -1. Sheree, Jenna, we good?
Yeah.
Jolene, you still listening?
I'm listening. Just take the magnitude at the end. Got it.
No problem. All right. Now, remember, we said that the S2O3 was the second step of the mechanism, which was the fast step. We want the rate for the slow step. The slow step involves the peroxide, the fast step involves the thiosulfate. So we got to relate the rate of the thiosulfate to the peroxide. And because the coefficients are 1 for the peroxide, 2 for the thiosulfate, we're losing 2 molecules of thiosulfate for every 1 of the peroxide. So if we're monitoring both, the rate of the loss of the thiosulfate would be twice as much as the rate for the peroxide. So the rate of the peroxide is half the rate of the depletion of the thiosulfate. So if the rate of the thiosulfate was 0.0085 millimoles per second, then the rate for the peroxide is 0.0043 millimoles per second. Okay. Jenna, if you didn't understand any of that, I want to go over the first slides to begin with, okay? With you later.
Okay, thank you.
All right.
Yeah.
So right now I've gone through the calculations. Anybody have any questions about what you do? Have to change all of the initial reactants to the final concentration. That's the first thing you have to do. You have to take the concentration of the thiosulfate, divide that by the clock time. That will give you the rate of the thiosulfate. You relate that to the peroxide by dividing it by 2. It's short and sweet there. Okay, let's get into the simulation. And now we're going to get to see Mr. Popovich be inept.
Second number,
I'm sorry, Jolene?
second secret number.
64. You're not going to have to worry about it, Jolene.
I just want to remind you so you have it for your video.
Thank you very much. Thank you very much.
Effectiveness, greatness.
I've already marked your presence here, so you're not having to worry. Jenna,
No, I'm doing it for the other kids.
Jenna, what I'm doing now is I need to see if people have watched the video. So I'm giving 2
Got it.
numbers, and 1 at the beginning, 1 halfway through, so that when I ask them what are the secret numbers, that way I know they've watched the video. Makes sense?
Okay. Yes, good to know.
It's amazing the tricks you have to do. All right.
It's like
I'm
you
gonna
have kids, you know what to do. Yeah. Sorry.
Okay. Nope. Is this what I want? Nope, that's not what I want. Where is? That's not what I want. My screen went away. Oh, that's the reason. I was looking up the Zoom videos. I think that's the title of it. There we go. All right. Anybody else have trouble submitting their post lab? Guys, when you submit things, please don't go through the calendar. Submit them through the modules. The modules are right. It's not my program. The person that developed the course did some funky things, and I don't know exactly what he's done. I know if you go through the modules, everything will be available to you.
Oh
So
yeah,
I'm
I had a
gonna go
question
to-
about the heat vaporization lab, but we're supposed to turn everything in on the one that was labeled the report sheet or the one that was just labeled heat vaporization lab intermolecular forces.
Okay.
Same problem. I just, like he said, just do it from the modules,
If you-
what you're looking at there.
Jenna,
Okay.
Jenna,
Same
I may
problem.
not be able to see your post lab. Okay, Jenna?
Okay.
So if you would take a picture of your post lab and email it to me, I'll make sure it gets graded, okay?
Okay.
All right, so anyway, this is what you should be looking at. Okay, we're seeing a non-simulated lab. This is how you will do it. You will go to start assignment And basically, all you got to do is hit upload file, upload all the pictures to that, submit assignment.
Yeah.
We seeing that?
Yeah.
Jolene, I take it this is not what you saw.
I did that the first time around. I scanned it in. To do it like that, you have to scan it in. You can't actually take a picture. If you want to take a picture from your cell phone, then you see it the way that me and Jenna saw it, which was it were two different
Ah,
assignments for
so
the same.
what you're saying is, in order to do this, you have to save the picture.
Scan it into your computer. Exactly. So it makes it difficult for people who don't have scanners. I did do it that way.
Wait, you can't just take the picture, upload it in your file.
If you do it that from your phone on Canvas, it showed two different ways to submit the same report labeled differently. So it was confusing because one said heat vaporization and one said something else. The name of the lab.
Can you upload a picture into a laptop?
You can, because
yeah, I just use my big PC. I don't know.
I'm sorry, you have to understand, I'm not technically savvy. What I would do is I would load my picture as a file into my computer,
Yeah.
and then that's going to be stored in your desktop as a file. Upload the file that way.
Yeah.
yeah.
That's the only way I know to do it. I don't
Yeah.
care how I get it. I just need to get it.
Yeah.
That's the way I do it. Like I'll take a picture with my phone and then just like airdrop it to my computer or send it as an email and then upload it as a file then.
Sounds good to me.
Yeah. Morning.
Okay, so I need module. I need to get out of this. Leave student view. Now, when I access it, it's going to be
What
a
happened?
little different from what you do. Okay. Yes. Okay. Okay. My account. Okay. There we go. Thank God. I think we have only one more of these. No, we may have two more of them. I think the equilibrium constant that we're doing on Thursday, I think that one is not through here. Any case, kinetics. Continue to laboratory simulation. Okay, we got to click some things here. Click.
I think I probably have to call EVS and ask them.
I don't know. Yesterday was the same thing. I felt like, oh, and there's no paper towel even here.
Yeah.
My goodness.
Hey, I got it right. Yay. All right, here's the simulation.
I don't know. If they're like,
Okay, it tells you. Use
I'm
the
sorry, what?
thermometer. Pick up the thermometer. Put it in
Oh
the
yeah.
solution.
But I think it's just like completely empty. But the girl is on the floor who's in charge of that. So I'll just ask her about it.
That would be great. Thank you.
Mhm.
Yes, well,
Okay, put the thermometer in. If you have to zoom in, but if not, just record the temperature as exactly. It's 25.0. If I put in 25, it's going to give me an error message. It has to be exact. Okay. Now, put the thermometer back down. You're going to reach in, grab a 10 milliliter pipette. It tells you to add 10 milliliters of the iodide solution. So you put it in the beaker and you're going to choose the 10 milliliters. Take the pipette over, grab the pipette, put it over into trial 1. Now, if you just put this right there, that's enough to get rid of it. Now it says to take the 1 milliliter pipette, add 1 milliliter of the thiosulfate. Okay. Use the 10 milliliter pipette to deliver 2.5. Oh, 2.5 of water. Grab it,
Mhm.
put it over here. Get rid of the pipette. Grab a stir bar, stir bars, stuff it in the trial. Take the beaker, put it on the stirring thing. Click the stir thing on. Can you tell I've done this a few times, ladies and gentlemen? All right, so I've put 10 milliliters of this in there, 1 milliliter of that in there, and 2.5 milliliters of the DI water in there. I'm going to take the 10 milliliter pipette. I am going to grab 7.5 milliliters because that's what it tells me to do. Now, this is going to be, it's not going to be super quick, but it's going to be quick enough that you are going to have to realize what you're doing. Take the pipette, grab it. You're going to shove it into the waste and you're going to put the pipette right about where I showed you. And if you don't stop it correctly,
There.
if you don't stop it correctly, what it will do is it will say, time, it took too long, start over everything again. So it took 16.5 milliliters. So they've given you the original concentrations. They want to know how much of each reagent you put in there. And time was 16.5. Observations. I don't care.
Blue.
It turned blue. Just enter something in there. Okay. What they're really wanting you to do is you change the concentration of the peroxide. That affects the time. What you're supposed to do is say something like peroxide concentration increased, therefore reaction time was less. Peroxide concentration decreased, therefore reaction time was increased. That's really what they want there. We'll leave this right here. All right, now, initial concentration of my iodine. My new volume, 10 plus 1 plus 2.5 and 7.5, that adds up to be 21. So to get this initial concentration, I take my initial concentration of my iodide, 255.8. I put 10 milliliters of that solution in. So M1V1 equal M2V2. I multiplied the 255.8 by 10. My new volume was 21. So I now divide by 21. That gives me 121.8 millimoles. Notice, oh, that's going to give me a wrong answer. Gave me a wrong answer because this was 3 sig figs and the 21 was 3 sig figs. So I have to go through and make that answer 3 sig figs. Now note, the thiosulfate only has 2 sig figs and the peroxide only has 2 sig figs for the milliliters. Apply accordingly.
Okay.
Okay, initial rate. All right, what they want from this is they want the change of concentration of your thiocyanate divided by the time divided by 1/2 because they want the rate for the peroxide. So I have 2.2 divided by 16.5, divide that by 2, I get 0.067. Okay, are we good, ladies and gentlemen?
Mm-hmm.
I believe. Oh, yeah, the other crappy thing is you gotta put this
Dump it.
away. Okay. I don't know if it's gonna allow me to go on. It's not gonna allow me to go on. And literally speaking, guys, for me to do all 6 trials, it would take me 20 minutes or so right now that I know what I'm doing. I believe at the end there, the last thing is you're going to, after the first 3 trials, you're going to have water bath, and then you're going to have a little bit of a heating thing, I think. Or you have a water bath and you add a catalyst. One or the other thing happens. Bottom line, just do the directions, and it's going to ask you some questions in the post lab based upon what you've done here. Any questions as to the simulation or what you're being asked to do now?
Mm.
Okay, Jolene, if
Yes.
if your kids will let you, you can go back to sleep now.
Yeah, no, I have to get up. I have to study for my chemistry
And your,
test.
and your chemistry test.
Biochemistry.
You're not taking chemistry from me?
No, I already took this class, remember? And then
Ah.
I missed the final exam. I had an emergency and I didn't know you could do the eye drop or whatever it's called because I don't know those tricks and don't read the manual. Didn't read the, I didn't know I could do that. So I passed the
lecture.
lecture, yeah,
Okay.
but I waited too much for the lab.
We'll get
And
you
that
through this one.
5 years ago.
We will get you through this one. Anybody have any questions for me? Okay.
I think I'm good.
Jolene, Shari, you can go. I have nothing more for you, Jenna.
Thank you.
I just kind of like want to explain what's
I
going
got
you.
on.
Oh, just a quick question. So, we're not going to have another lecture like today for, no, another.
No, there's not there is not a lecture Zoom today. That's because
Okay.
there's a test. Okay.
Okay.
Sometime between now and 5 p.m., you have to take the lecture test. And that's what we're going to do. Come on,
Okay.
Shari. You guys, I've seen your minds after you take tests, and I know what my mind was like after I took a test. It's jelly. I wouldn't get anything out of you anyway.
Yeah.
Okay.
Okay,
All right.
Shari, I'm going to go over the first slides with Jenna real quick, and then
Okay.
I'm going to be out of here. If you want to stick
All
around,
right.
please feel free.
Okay,
But
I have
other
to get
than-
back to work, but thank you so much.
You take care, Shari.
You
Shari.
too. Bye.
Okay, Jenna, what's really happening? We're studying this reaction.
Okay.
The overall reaction we're studying is acid reacting with peroxide and 2 thiosulfates to make 2 waters and S4O8. That is the overall reaction. If I was going to look at the individual mechanism, I've got a slow step and I've got a fast step.
Mhm.
Okay. To determine the overall rate of the reaction, I need to determine the rate of the slow step, which I can get by determining the rate of disappearance of the H2O2.
Okay.
All right. Now, the trouble with this is both of these reactants and products from both of these little reactions, both of them are clear. So I have nothing to observe when things change. So I have to employ a third reaction. And the third reaction is that I3 minus, when you add starch to it, turns a blue instant color.
Okay.
All right, so I'm going to employ a trick. The first reaction is going to create the I3. The second reaction destroys it. Okay? So if I add, excuse me, if I add less thiosulfate, then I have peroxide. Then my thiosulfate is going to be my limiting reagent. It's going to run out. Does that make sense?
Yes.
All right, so
Mhm.
as long as I have thiosulfate, I have no I3. If I have no I3, the solution stays clear. But the minute I run out of thiosulfate, the I3 appears, it reacts with the starch, I get a blue color. So I can now monitor my reaction so that
Mhm.
I know, if I know how much I start with initially of the thiosulfate, I know how much I have when the solution turns blue. I have none left. So I have my change in concentration from the 0 left minus the amount I had originally.
Okay.
All I got to do now is divide that by my time it took to turn blue. And I've got my rate of disappearance of my thiosulfate. You're with me now, right?
Yes, it makes more sense now.
All right. Why they don't bother going into this, I'll never tell you. But I mean, it took me 5 minutes to make that explanation, and it's clear.
Yes.
All right, so now I have the rate of disappearance of my thiocyanate. But remember, that's my fast step.
Mhm.
I have to relate it to my peroxide. Now, if you remember, I went through this in lecture where the rate, I can relate the rate of one thing to the other by multiplying the rates by 1 over the coefficient. Do you remember that slide?
Yes.
So if I look here, my peroxide is 1 over 1. That's going to be equal to 1 over 2 of the rate of my thiosulfate. This is why in that last step, remember, I got the rate of the thiosulfate, then I divided it by 2. That's the reason I'm doing that. I'm relating the
Okay.
rate of my thiosulfate back to my peroxide because basically, if you think about it, I'm using up 2 of these for every 1 of these. So this is going to disappear at twice the rate that the peroxide disappears.
Mhm.
The other thing is you have to remember that, I think we're, yeah, nope. One second. I put it somewhere. I don't know. What I'm just going to tell you this. Remember when we're dealing with reactants,
Mhm.
we're looking at the final concentration will always be less than the initial concentration because we're using the stuff up. So when I figure out the rate at first, it's going to be a negative. I have to multiply that by a -1 because rates are always positive.
Okay. Yep.
So basically, if I'm looking at the rate of a reactant, the initial calculation will be a negative. I just have to realize that I have to multiply that by a -1 to get the real rate.
Okay.
And I think this is about where you started.
Yeah. Yeah. Right here.
Okay, so as I said, I wanted to lead you through that to give you a
Thank you.
further understanding of what's going on in the experiment.
Yeah, sorry I was late. My alarm didn't go off, and then I was like, crap.
Jenna, believe me, I am not a morning person. Believe me, this is the worst I'm going to look all day. And believe me, there's not much of a change. So again, I wanted to make sure that you were aware of that. And so
Okay.
that, yeah, it's no problem. Okay.
Okay, awesome. Thank you so much. And I did send you that email of the heat of vaporization lab.
Okay.
So let me know if you're able to open that and everything. And then, yeah, I'm all good. Thank you.
Thank you, Jenna. You take care. And you're taking a test later.
Yeah, I think I'm gonna take it around 12. So have a little extra time to study this morning.
Good enough. Good enough.
All
Read
right, thank you.
read the thinking questions carefully. They're going to
Okay.
be the multiple choice at the end. Read them carefully.
Okay. Okay, good to know. All right, thank you.
Take care.